Namaskar everyone. So today we will be solving this problem which earlier I told you to solve. Now the solution will be provided. See, this is a good problem. There is a sectorial gate. First of all, I am showing a 3D view of this problem so that everybody can feel the problem in detail. So there is a sectorial gate is there having an angle of 60 degree, and this gate is kept over a spillway. As you can see that this is the spillway I have shown in the diagram. Now over this on the left hand side, this sectorial gate is completely submerged in water from the left hand side. So in this problem basically you have to find out the total hydrostatic force acting on this sectorial gate. So this sectorial gate, as you can see in the problem, it is a curved surface. So we need to find a horizontal force acting over this surface and a vertical force acting over this surface. Now let us solve the problem in detail. So this diagram was 3D view. Now this is the 2D view of the problem. This is the 2D view of the problem. So this is the sectorial gate is there, and if I represent water, the water is on this side. This is the free surface of water, and I need to find out the total hydrostatic force acting on this sectorial gate. Now the total hydrostatic force, as we all know, that the total force is going to be under root of horizontal force acting on this curved surface square and the vertical force acting on this curved surface square. So first of all, let us try and find out the horizontal force acting on this curved surface. Nice. So if I need to find horizontal force, as we all know, over a curved surface, the horizontal force is equal to the hydrostatic force acting on the vertical projection area. So if this is the curved surface is there, this is the curved surface is there, the vertical projection of this curved surface is going to be a rectangle. The vertical projection of this curved surface is going to be a rectangle, and the rectangle, that is the vertical projection, it is going to be something like this. It is going to be something like this. Now per unit width you have to find the answer. So therefore the width of the gate, let us take it to be 1 meter, and this height, so you see this height is given as, this length is given as 5 meter, and this angle is given as 30 degree. So from trigonometric relations you can find this, so this will be 5 sine 30 degree, and when you calculate it is going to be 2.5 meter. So it is 2.5 meter. So if this is 2.5 meter, this is also 2.5 meter. So the total length if I talk about the base of this triangular thing is 5 meter. It is 5 meter. This is the thing. So this vertical projection, the height is going to be 5 meter. Now from here we can find the horizontal force acting on this curved surface. So the horizontal force calculation acting on this curved surface is going to be WA x bar. W, as it is water, so it is 9810 multiplied by the area of the vertical projection. And area of this vertical projection, as you can see here, that it is 5 cross 1. So it is 5 cross 1 multiplied by x bar. X bar is the distance of CG from the free surface. As it is a symmetric figure, the CG of this symmetric figure is going to lie exactly in the center. Exactly in the center is going to lie the center of gravity, and the distance of CG from the free surface of water is going to be 2.5 meter from the free surface. Excellent students. So multiply this thing with 2.5, and when you calculate this answer is going to be, but in this problem the acceleration due to gravity is given as 10. So we need to take acceleration due to gravity as 10 in this problem. Now if we take 10, the the specific weight of the fluid is going to be 10,000 if we take GSA. So it is not 9810, it is 10,000. It is 10,000. 1000 into G, that is 10. Now if you calculate this is going to come out to be 125 kilonewton per meter, because you have taken the width to be as 1 meter. Excellent. So this was all about the horizontal force. Now let us move on to the vertical force acting on this sector. Now to find out the vertical force, as only this black color curved surface is inside water, so in the classroom also it has been taught, you can relate with classroom, that the vertical force acting on this curved surface is going to be weight of the fluid contained by this yellow color portion that I am showing here. Weight of the fluid contained by the yellow color portion. Now to find the weight of the fluid contained by this yellow color portion, we need to find the area of this yellow color portion. But to find the area of the yellow color portion, first of all we need to find the total area of the sector. Total area of the sector, first of all we need to find. So we need to find this total area of the sector that I am highlighting here. Total area of the sector. And from that total area of the sector, we are going to subtract this red color area, which is the area of the triangle. So from total area of the sector, if I subtract the area of the triangle, then I am going to get the area of this yellow shaded portion. Then I am going to multiply it with the width. Then I will get the volume of this yellow color portion. So first of all, I need to find the area of the sectorial region. And from mathematics, we all know the area of the sector is given by theta divided by 360 into pi r square, where the radius of this sector is equal to 5 meter. It is equal to 5 meter. Now, so theta, the total inclusive angle is 30 plus 30 is 60 degree. So theta is actually 60 degree divided by 360 into pi r square. Radius is 5 square. So therefore when you calculate this, you will get the area as 13.089 meter square. So this is the area of the sector. I'm writing here area of the sector. Now from this area of the sector, you have to subtract the area of the triangle. So first of all, we need to find the area of the triangle. So area of triangle, that is shaded with red in our diagram. Area of the triangle is going to be half base into height. The base of the triangle is 5. So it is 5 into height of the triangle. Now again, using trigonometry, we can find this height of the triangle. I will shade it with a different color. Let us say I'm shading it with yellow. This height I'm talking about. So from trigonometry, this height is going to be 5 cos 30 degree, and 5 cos 30 degree is going to come out to be 4.33. So this height, multiply this with height, that is 4.33. So the area of the triangle, if you calculate, is going to come out to be, the final answer is going to be 10.825 meter square. Now from area of the sector, I have to subtract the area of the triangle to get the area of the shaded region. Area of yellow color region. Now area of yellow color region is going to be the sectorial area, that is this, minus the area of the triangle. So it will come out to be 2.264 meter square is the area of the yellow region. But to find the weight of the fluid contained in the yellow region, we need not find the area, we need to find the volume of the yellow shaded region. So therefore volume is going to be area multiplied by depth, and per unit width you have to find the answer, so depth will be 1. So therefore my dear students, the volume of the shaded region, the yellow shaded region, is going to be 2.264 meter cube. So it will be meter cube, my dear students, because it is the volume. So it is meter cube. Excellent. Now from this volume, that is 2.264, we will find the vertical force acting on this sectorial gate. So the vertical force is going to be weight of fluid contained by yellow region, yellow shaded region. Now where is yellow shaded region? I have already shown in the diagram. You can see clearly the yellow shaded region. Now the weight of the fluid contained by yellow shaded region is going to be, it is going to be rho into G. Rho into G is going to be 10,000 multiplied by 10,000 multiplied by the volume, and volume is 2.264, my dear students. So therefore when you calculate this, the vertical force is going to come out to be 22.640 kilonewton per meter is the vertical force. Excellent. So vertical force is 22.640 and the horizontal force is 125 kilonewton per meter. Let us find the resultant force. So everybody now knows from this problem that the resultant force is going to be horizontal force square plus vertical force square. And when you calculate this, you are going to get the answer as 127.03 kilonewton per meter. So that's your answer. Again, a fantastic problem.
So let's understand the concept of symmetrical and asymmetrical face milling. So focus here. This is the diameter of the cutter, and the center of the cutter passes through the central axis of the workpiece. So this is the cutter, and this cutter passes through the central axis of the workpiece. तो देखो अभी जब इसने टच किया तो क्या मशीनिंग कंप्लीट हो गया? नहीं. मशीनिंग कंप्लीट कब होगा? जब पूरा कॉर्नर, पूरा विड्थ कटर के नीचे आ चुका होगा. तो हम कह सकते हैं दैट मशीनिंग इज कंप्लीट. तो ये कंपलसरी अप्रोच मिल गया अपने को एक्स. ठीक है. अभी सेकेंड केस में देखो, ये है दूसरा कटर. अब ये वर्कपीस के बीचों बीच ट्रैवल नहीं कर रहा है, ये ट्रैवल कर रहा है वर्कपीस से थोड़ा सा दूर. ठीक है. अब ये देखो ऊपर वाला कॉर्नर कवर हो चुका है, लेकिन नीचे वाला कॉर्नर अभी कवर नहीं हुआ. अब जाकर हम बोलेंगे ओके बोथ द कॉर्नर्स आर अंडर द कटर. तो ये जो डिस्टेंस आपको दिख रहा है दैट इज द कंपलसरी अप्रोच. और ये डिस्टेंस दिख रहा है ना कटर सेंटर और वर्कपीस के बीच में, इसे कहते हैं ऑफसेट. और ये है W/2. ये जो ऑफसेट है इसे आप कह सकते हैं Y. दिस इज द केस ऑफ एसिमेट्रिकल फेस मिलिंग, दिस इज द केस ऑफ सिमेट्रिकल फेस मिलिंग. तो सिमेट्रिकल फेस मिलिंग में कंपलसरी अप्रोच छोटा होता है एज कंपेयर टू एसिमेट्रिकल फेस मिलिंग. सो वेरी